Hi. Exam 2 review. Yeah, it's one of those days, right? So the next class is going to be exam first thing in the morning, and we are covering chapters 8 plus 9. Now, for chapter 8, we have 8.1 through 8.9 minus 8 point, I believe 7 was the one with the table of integrals that I can't give you. And I'm going to put it this way. No 8.7. And then for chapter 9, we only have 9.1 and 9.3.
So 8.7, you're going to stick to the basic, not basic, but like integrations that we can actually solve without having to.
Yes.
Without having to have prior knowledge to one of the 6 pages.
Yes.
Okay. The other thing I wanted to ask about was going into the Simpson rule, trapezoid rule.
Yeah, we'll deal with that when we get there. So let me just put the point, and then that's going to be a question. Write it down so you don't forget. 10 problems. 100 points. Well, 107 if you do the quizzes, starting tomorrow at 6. And 90 minutes in class. So this is what we have. And the topics or things you need to know. I understand that U sub is not right here, but so many things depend on U sub that you are guaranteed to see it 3, 4, 5 times at least as a byproduct of other methods. So know your U sub. Plus, it does show up in 8.1 as well, so it's there. I'll say 5.5 and 8.1, but it's everywhere. All right, so we have biparts, which is in 8.2. 3 trig integrals 8.3, 4 trig sub 8.4, and I'll put like this and I'll say link, right? Because that's together. 5 partial frac, then 8.8 so number 6 is numerical, which breaks into midpoint, trapezoid, Simpson, all of those, 8.8, and number 7, improper, which breaks down into 2 categories, type 1, type 2. Number 8, differential equations, worrying about definitions from 9.1. So classification, let me put definitions, let's put definitions and classifications, and classifications 9.1, and then separation of variables 9.3. So that's the exam. Now you're probably going to say, well, what happened with 8.6? 8.6 is choose your method. So that's technically everything, right? You will be choosing your method in most of the problems. So 8.6 is the crucial section that you use, and that's that one class where we had a whole bunch of integrals on the screen, and then we went for 2 hours discussing which method solves which integral, and I told you to take detailed notes because there was one that I was not streaming, and it was the most important one of the whole chapter, because I had to display the page from the book that had all the problems, and then you guys, then we discussed and you took the notes on it. So this is the exam, and I'm just going to say that over here, for these two, any method 8.1 through 8.5 can fall into it. So it could be basic U sub, could be trig sub, could be partial fraction decomposition. Anything goes inside the improper integral. Numerical, you will just be multiplying and adding and so on. Differential equations, separation of variables. Again, any integration method. Again, right, any integration method 8.1 through 8.5, because once you separate the variables, you have to do two integrals, one on left and one on right. Those integrals could be partial fraction, could be separation of, partial fraction or U sub or trig sub or whatever. Keep in mind, so note, try U sub first. Right? Try the U sub first, because if the U sub can work, there is no reason to do trig sub or, partial fraction decomposition or something crazy, right? When the U sub works, when it's so easy to hide, right? Partial fraction decomposition question with a hidden U sub is the biggest slap in the face, right, on this exam. Because partial fraction decomposition takes a very long time to solve, right? And U sub is a joke. So if you have, even if you have the simplest possible partial fraction decomposition, like let's say you have x minus 3, x plus 7 dx, and on top you have dx plus 4. That's a U sub question. It's just ln of the denominator. It's a U sub question that you literally, if depending on the level of your integration sophistication, right? It could be just you write, oh, yeah, the answer is ln of absolute denominator plus c, just by looking at it. Because if you are to multiply denominator, right, so this is U sub. Why? Because denominator here is U equals x squared plus 4x plus minus 21, and the du is 2x plus 4, which is exactly what you have on top. If that was 2x plus 3, it's partial fraction, right? But since it fits, it's a U sub. So if I have x plus 4, partial fraction decomposition. If I have just x, partial fraction decomposition. Anything other than 2x plus 4, partial fraction decomposition. Can you use partial fraction decomposition now? Yes! But you can also use U sub in this one case, right? When the denominator, when the derivative of the denominator is exactly what you have in the numerator. So try U sub first. Would you be wrong if you do here the partial fractions? No, you won't be wrong, but it's going to take a long time, right? Because you have the whole page of calculations to figure out the coefficients a and b, and then you have to solve the separate integrals and all of that kind of stuff. So this could be done with the u sub. So, if you spot the u sub and you do the u on a side and you see it works, don't second guess yourself, right? It's what it is. You just keep going from there. So this is it, what I wanted to say. Now, what are your questions? Yes?
So with the numerical problems, are we going to be actually solving using the sum total? So we're going to be solving the function, finding the points, and then actually doing the subdivisions off that? Or are we going to be given the points on the graph that we're going to be using as the subdivisions?
You will be given the interval, and you will have to break it down into number of points, and then you will be computing y values. So it will be the full problem. So for numerics, a, b, and n are given. Nothing, and f of x, obviously. So f of x, interval a, b, and then are given to you. And then you will have to go and you will have to say, okay, this is my a, this is my b, and this is how many of these I have, right? So you will calculate that delta x is b minus a over n, which each one of these delta x is over here. And then you will go a plus delta x, a plus 2 delta x, right? You will keep adding these.
Okay.
And then you will be computing the f of x's, and then you know the formulas, right, with the patterns. 1, 2, 2, 2, 2, 2, 2, 1 for trapezoid.
1, 4, 2.
1, 4, 2, 4, 2, 4, 2, 4, 1 for Simpson. Very good. Yes?
Can you quickly go over a improper integral that has to do with trig? So
How about we go with a medium speed? Because if I go real quick, you might not catch all the words. So which integral? Do you have an idea?
just where you have sine or cosine on the bottom, so occasionally you'll get 0 on the bottom.
Did you find those problems in the book?
No, I'm just thought about it and thinking that it may come up. So
you would like to say integral of tangent x from
0 to 2 pi.
0. We can go 0 to pi. It's going to be crazy enough. So this is a hot type 2 spicy improper integral because the issue point pi over 2 is buried inside. So type 2, because we know VA at x equals pi over 2, and that's the bad point. So I have to break this into 0 to pi over 2 tangent x dx plus the integral pi over 2 to pi tangent x dx. And now give it two separate limits. Limit b goes to pi over 2 from the left. No, lies from the right. Of integral 0 to b. And then tangent I'm just going to write as sine over cosine. We use sine over cosine here because that's how we integrate tangent. Unless you memorize the integral of tangent, it's not a basic integral.
Absolute value secant.
Yes, ln of absolute value of secant, yes. It's not a basic integral, so if you don't know it, it's still okay to do these things. Plus, limit a goes to pi over 2 minus, which is from the left, integral a to pi, and then we have, again, sine x over cosine x dx. So these are the two. And all I need to do is now integrate. So limit b goes to pi over 2 plus from the right. Integral of sine over cosine, I'm using a u sub. For both of these integrals, u equals cosine x, du equals negative sine x dx. So I need to put in these minus signs, so the minus signs will travel with me. And I have integral of du over u. So du over u. And now that I have du over u, plus the other one will also be limit a goes to pi over 2 minus integral du over u. So this becomes negative limit of ln of u, which is negative limit ln over of cosine x. And this negative can change it into secant, but it's much easier if you compute with a cosine. So I am not going to change it into a secant because it's easier to compute with cosine. I have my limits from 0 to pi. There is still plus the second integral, but I'm not worrying about that because I know that the first one is going to diverge. So I'm skipping. So minus limit b goes to pi over 2, and I have ln of cosine of pi minus cosine of pi minus ln cosine of b. And now here is the $1 million thing, guys. This one goes to negative infinity. Because when you plug in pi over 2 for b, cosine of pi over 2 is 0, and then ln of 0 is negative infinity. And that makes the whole thing go. So I only did half of the calculation, and I found that one of the two integrals is divergent. As soon as a small part of the problem explodes, the whole problem explodes, right? So now obviously on the exam you will be still working out this other half over here because they look the same, it's just more writing, but I want to give you now more time to ask questions. Does that make sense? Mm-hmm. So there's your problem with the cosine in denominator, the improper. Anything else?
The test start 8:30 in the morning?
We'll probably start around 8:45, 8:50, because the issues with icing and everything else. This morning I was 11 minutes late because I did not anticipate that my car will be completely frozen.
How long is the test?
It took 90 minutes.
Couldn't we start it at 10?
No, we have to cover the other 10 sections. We have 4 classes left.
Could we start the 10
And
section first and take a break and do the test?
we have 2.5 chapters to go. Let me put it that way. And 4 classes.
And then break for it.
So we'll start at 8:45, about 8:45, to accommodate for the icing conditions. But we have to, because I have to finish chapter 10. And then after chapter 10, if we have time to start 11, because there is still exam 3, which is on 10 and 11. And then there's chapter 12, and then the final. We have 4 classes left after the exam. We don't have luxury of postponing stuff.
No, you're not postponing it. I'm saying you could just start. The test
I know, but you are fresh with the knowledge. If I talk about series for 2 hours and then you take the test on integration,
But you can start at 9.
the test, I could, if there are questions. I believe it's December 12, 14, 15, whatever a Saturday is. 14? Okay, so that's when the final is.
So you are counting with the Thanksgiving Saturday?
Saturday, that will be a review day for people who want to come in. We'll be in for like 2 hours, just reviewing a whole bunch of stuff.
So basically have 3 classes.
Yes.
I mean, well, no.
Yeah.
All we need is a C meal.
So we have 4, 7, and 11 sections to cover. We still have 11 sections
My district is in desperate need.
and 2 exams. So
So we have class
60 grand a year plus benefits.
after the test next week, and then 16 planters, and then
And
on
it's
the
like,
7th
it's an
gonna be
actual
third.
career now, it's not like it's just.
that will be up to you. I don't know.
Career?
It's the only day, like, unbelievable, because the next week is gonna be the final.
Okay, if you say so.
I'm just saying, like, if you don't do that day, we're not gonna do it.
Oh, in 10 years, yeah.
Because now we're.
Any other questions for exam 2 material?
Other than that, most of it's got.
So differential equations, you separate the variables, one variable of one kind on one side, the other one on the other, integrate both.
So with partial fractional decomposition, so there's a,
Oh yeah, there is one important thing for that.
so I was going to ask, because when there's a term at the bottom, but then there's like when there's a term or a squared term, like you break it up into the term and the squared term.
Yes.
And then the other thing is when there's a quadratic and then a polynomial quadratic, you break it up into the quadratic and the polynomial quadratic, because that's repeating and the regular.
Yes,
and the regular
yes.
Linear and then repeating.
The
So
most
I think I
im-
always got mixed up.
Well, yes. So you have those 4 rules.
But then you keep the same form on top, so it's still linear gets 1, 1, and then quadratics get bxc, and then
Yes.
letter x letter.
Yes.
Okay, yeah. That was
The only thing that I've seen as a consistent mistake is trying to use partial fraction decomposition in a wrong problem. You cannot use partial fraction decomposition if you only have one term. You have to have at least 2 terms in the denominator, because partial fraction decomposition is supposed to break them into 2 separate, 2 factors, not terms. If you have single factor, it cannot work. You need to have at least 2 factors in the denominator, so you can use those 2 factors to break into 2 terms later on. Yes?
One of your factors is ln x. How is that represented?
Can do ln x because it's not a polynomial. Partial fraction decomposition works solely on the problems that are 100% polynomials. No square roots, no ln's. If you're seeing ln, probably there is some game of u sub or by parts in there. If you're seeing a square root, could be by parts, could be u sub, or could be trig sub, right? So if you see a square root, it's one of the 3, right? If you see ln's, right? Partial fraction decomposition is 100% polynomials only, nothing else.
That could be like a giveaway if you see that it's just purely
Polynomials?
functions or polynomials.
Well, they could also be trig sub, but if you have single, so that's one of the factors where the people get confused, because when you look at the integral of, let's say, 3 divided by x squared plus 4, right? It's not a partial fraction decomposition. It's a trig sub. It's a trig sub because you only have one factor here, right? So you can't set up your partial fraction decomposition.
It's amazing how innocent that
Is
one
that
is.
sec square?
And how vile it really is.
Yeah.
Oh, this one I
Well, that's not even hard. You just pull 3 out and then it's.
yeah. This one is what? This is a basic integral from Calc 1. But
Oh.
Then you just. Oh,
Oh,
That's
yeah,
so for sure.
tan, like sec square
So-
tan equals tan.
I was
Equals tan, yeah.
Dude, what's your jacket?
Oh, this is a drum major jacket I bought in Asbury.
Oh, that's cool.
Freddie Mercury, yeah.
The hell? I just noticed that.
um,
It's awesome.
so,
Okay, let's finish math, and then I gotta take a look at that.
so I was thinking with the arc length formula, when it's not a quadratic minus itself that's just going to cancel out, can you use tangent sub? Can you sub in tangent to that? Because it's after you do the initial. Yeah, after you do the initial, you can just do tangent sub it in, and then
Yes.
break it down so you can get rid of the root. Take care of the, because I was looking at that and I was thinking about that when I was working on the homework. So you just, not that it's going to make it easier every time, but it makes it easier to break it down into steps that you just unwind theta.
Mm-hmm.
Before I leave, can you show me? I haven't seen my test grade for exam 1 yet.
Oh, you also
Oh,
have
that's
that.
in my office. We have
Do
to
you
go
have it
there.
on file? Like, I just need the number.
Nope. It's in my office.
Can I visit you during your office hours?
Yeah, right now.
Okay.
Go there. Yep.
You also need to know
Alright.
lab.
Oh yeah, I also need to know if my lab was turned in. My name's